Hi, everybody. So, in today's video, which is the first video of Chapter 8, we are going to be doing a couple different things. And the focus is going to be on finding average values of integrals, but I wanted to start by doing some review of things that your calculator can do. So, um, let's start with this. Looking ahead at the next two problems, so at this problem and this problem, you're going to notice that when we do finding a derivative on our calculator and when we do finding an integral, I'm going to be asking you to use the same equation for both. A lot of times on the AP test in an FRQ where you're going to be having multiple parts to the problem, this is what's going to happen. They're going to give you one equation and they're going to ask you to do multiple things with it. What your calculator can do is actually store a function so that you don't have to keep typing it in over and over again. I'm going to show you how to do that kind of right now so that you can find a derivative and find an integral on your calculator. You'll notice there are little tiny calculator pictures throughout this unit. Any problem where you're intended to be able to use a calculator will have one of those little pictures next to it. So you'll know this should be a calculator question. So let's say that I'm doing a problem on the AP test and I look ahead and I go, wow, this is kind of a long equation and I'm going to be using it more than once. I'm going to be using it to find a derivative. I'm going to be using it to find an integral. I might be using it to look at a graph. I want to avoid having to type it in more than one time. So what I'm going to do is on my calculator, I'm going to go to the y equals, which is where I type in functions to make a graph, and I'm going to type in this equation one time into my y1 slot. So I would have 10 plus parentheses zero point 0.8, and then I know that the equation says t, but on our calculator we're going to use an x. Then I would have sine, and then I can type in alpha y equals to make a fraction x to the third power over 100. Now that I've got my equation typed into my y1, I can actually tell my calculator to keep recalling that equation rather than retyping it in. So if I wanted to, for example, find the derivative at 7, but I want to use my calculator, on my calculator, I'm going to go back to my home screen. I'm going to hit the math button and I'm going to go down to option 8. Now you could scroll down and actually go to option 8, or you can just hit the number 8 on the number pad. It says n derive, which means a numerical derivative, a derivative at a certain number. Now it's going to pop up with this kind of nice arrangement for finding a derivative. I want the derivative with respect to x. And now I need to put the equation that I'm using inside of this parentheses. Rather than retyping it all in, I know that that equation is stored in my y1 spot. So I'm going to go, and this is where it's kind of new, I'm going to go to vars, which stands for variables, and then where it says y variables, and then where it says function. Do you see it gives me an option of which which y function do you want? I want y1, that's where I put this equation. I want to now plug in the number 7. So what this means is take the derivative of the equation in the y1 spot and plug in the number 7, and it's going to give me my answer, which is negative 8.119. Now, on the AP test, we are always going to be rounding to 3 decimal places, and you don't even really have to round. You can actually just stop after 3 numbers. Technically, if you were to round this, you could do negative 8.120 because the 5 would bump everything up. But on the AP test, they don't care. They just want you to give them 3 decimal places. The next thing we're going to review is we can actually find an integral the same way. So I'm going to go back to my math menu. And instead of math option 8, which gives me a derivative, I'm going to do math option 9, which says function integrate. So integrate this function. I want to integrate from 0 to 2. So I'm going to type in the 0 and the 2. And I want the equation that I've already stored in my y1. So again, I'm going to go to variables, y variables, function, and choose the y1 option. And then I'm going to type in dx because I always need to close my integral, and I'm going to hit enter. And this is going to give me 20.051. So cool stuff that your calculator can do. It can do it for you. The other thing we're going to really focus on in this unit is interpreting the meaning of your answer. I know we've done this throughout the unit, throughout the year, but I found this cool strategy, and I think it's a good way to sort of organize your thoughts of what components need to be in an accurate interpretation. We're going to call it the NUT strategy. And so the N in this strategy stands for the noun. The noun meaning what is it you're actually measuring? The U stands for the units. So, what units are you measuring in? And the T stands for the time. So, at what or over what time interval. So, every interpretation needs to have a noun, it needs to have units, and it needs to have a time. In this problem, h of t represents the height of a tree in meters, t years after it is planted. So, h of t represents the height of a tree in meters, t years after it is planted. Interpret the meaning of h prime of 4. As soon as I see h prime, it tells me I'm taking a derivative, and a derivative is always a rate. At a specific number, at t equals 4. So that's going to help me figure out my noun that goes in my sentence. So here's how my sentence is going to go. h of t represents the rate of change of the height of the tree. So that's my noun. It's the rate of change of the height of the tree. Then we need units. So measured in, and units here would be a fraction. You're finding a derivative, which is a slope. So it would be measured in meters per year. And then we need a time. Since this time is at 4, it's not over an interval, it's specifically at 4, we would say at t equals 4 years. So we have a noun, it's the rate of change of the height of the tree, the units measured in meters per year, and the time at t equals 4 years. For part B, R of t represents the rate at which water drains. Interpret the meaning of the integral. If we integrate a rate, we're getting the amount of stuff that has changed over the interval. So if I integrate the rate at which the water drains, I'm getting the amount of water. Rate at which the water drains in liters per hour. Interpret the meaning of the integral. Those are kind of the key points. So I would say the integral from 1 to 8 r of t dt represents the amount of water that drained and now we need units, so we're going to measure this, measured in liters, because when you integrate, you're multiplying the units, so it's liters per hour times hours is just liters. And this time, it's over a time interval from 1 to 8. So we would say from t equals 1 to t equals 8 hours. So as you can see, we've got the noun, the amount of water that drained, the units measured in liters, and the time from t equals 1 to t equals 8 hours. All right, now that we've kind of done that as prep work, here's the new big idea. The big new topic is that we need to be able to use a definite integral to find the average value of a continuous function over an interval. Let's start with what an average value means. An average value is the y value that explains where a function would level off if we spread out all of its area equally. So what you'll notice in this graph is that the area we've accumulated is kind of a weird shape. If we were to add up all that area and redistribute it evenly, this area that's above would end up filling in this area that's below. So this line would be considered the average value, because that's sort of the leveling off point. If you were to redistribute this area, it would level off to that number. Another way to think about this is you're just finding the average. So in order to find the average of a set of data, you need to add up all of the values and then divide by however many values you just added. That's how we average anything. Add them up and divide by how many you added up. When your data is continuous, you can't just add the numbers. How would you possibly add this number and that 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 number, and then there's the ones in between? You can't. So in this case, we use an integral to add up the numbers, to add up the y values. Therefore, we've developed a formula for finding the average value. To find the average value, you integrate from the beginning of your interval till the end. And what that does is it adds up all of the y values. But then we need to divide by how many values we just added. So to figure out how many values you added, you need to know the width of the area you integrated. So to figure out the width, you would do b minus a. So you would divide by b minus a. So this does that, adds up all of the y's. And this divides by how many you added. However, this equation is really kind of messy. So what we usually do instead is we say, let's write it in a neater way by saying 1 over b minus a times the integral from a to b of f of x dx. And this is kind of the way we usually write our formula. So we're going to do a couple different practice problems to kind of get the idea of what's happening here. If I say, please find the average value of this function on the interval, then you need to know to set up that integral. So the average value will equal 1 over, in this case, the b is 2, so 2 minus negative 1 is the a, times the integral from negative 1 to 2 of your function, 1 plus x squared dx. Now I can simplify that a little bit by doing 1 over 3, because 2 minus negative 1 is 3, times the integral from negative 1 to 2 of 1 plus x squared dx. In order to do this computation, I need to do the antiderivative. Since the 1/3's on the outside, I'm just going to leave it there. I'm going to deal with the whole integral business, and then I'll multiply by 1/3 at the end. So the antiderivative here of this function would be x plus 1/3 x cubed plus c. And I need to evaluate that between negative 1 and 2. So I'm going to have 1/3 times, if I plug in the 2 first, I'm going to have 2 plus 8/3 plus c minus, and then if I plug in the negative 1 second, I'm going to have negative 1 minus 1/3 plus c. So again, I'm just going to work on the inside of this bracket. I'm not going to distribute the 1/3 until I'm done. So now what I'm going to do is simplify this negative by distributing. So I'm going to have the 2 plus 8 thirds. We know that the c's are going to cancel. And then I'm going to have plus 1 plus 1/3. 2 plus 1 is 3. 8 thirds plus 1/3 is 9 thirds, which is also 3. So I get 1/3 times 6, which would just be 2. So 2 is the average value of that function over that interval. Now, a second way that we are always assessed on average value is we look at a problem like this one. The average value of function f over the interval from -1 to 2 is -4. So they're telling me the average value. And the average value of f from 2 to 7 is 8. What is the average value of f from -1 to 7? Let's start by kind of writing in a mathematical way what we were given in the instructions. So I know the average value from -1 to 2 is 4. The ways to write that mathematically would be to say that 1 over 2 minus -1 times the integral from -1 to 2 of my f of x function is -4. A simplified way to say that would be 1/3 integral from -1 to 2 is equal to -4. That's kind of the first part of the sentence. The second part of the sentence is that the average value of f over the interval from 2 to 7 is 8. So I would say 1 over 7 minus 2 times the integral from 2 to 7 of f of x equals 8. So they're telling me the average value. This is the formula equals 8. So I would have 1/5 times the integral from 2 to 7 f of x dx equals 8. So that's what I know. What I want to know is what is the average value from -1 to 7. So what I want to know is what is the average value from -1 to 7. Now, in order to figure that out, I need to do 1 over 7 minus -1 times the integral from -1 to 7, which really means I need to do 1 over 8 times the integral from -1 to 7. Here's how we put all these pieces together. I need to essentially know the integral from -1 to 7, which would be what I get if I combine this integral and this integral. So what I need to do now is get this integral by itself. To do that, I'm going to multiply both sides of this equation that I've set up by 3. What that allows me to do is to figure out that the integral from -1 to 2 of f of x dx is actually -12. If I multiply both sides of this equation by 5, what that allows me to do is to figure out that the integral from 2 to 7 of f of x dx is 40. Using these two integrals and adding them together, I can go from -1 to 7, which means that my integral here would be worth 28. So what I need to do now is I need to do 1/8 times 28. If I simplify that so I can divide them both by 4, I get 7 over 2, which is option C. All right, let's look at another kind of problem. So this is a calculator question, and this one is in here because I really wanted to emphasize the difference between some of the vocabulary words we've seen throughout the year. You'll notice that this is a calculator question. And it says, on a one day, a strange weather system moved into town, and the temperature in degrees Fahrenheit over the next 24 hours was given by this formula, where T is in hours. It's going to ask me to do several things with this formula. What is the average rate of change? What is the rate of change? What is the average temperature? So what I'm going to do to make my life easier is use that cool calculator feature, and I'm going to type this equation into my y1. So 70 plus 2 sine of x over 2 minus x over 2. You could actually make those fractions if you want to. I just put them as fractions in parentheses as division problems. So now this is in my y1. I always like to make a note of that this is in my y1, just to remember. Sometimes you will have problems where you have more than one equation. It's just good to know which one is where. Part A here says, what is the average rate of change of the temperature over the 24-hour period? Include units. Average rate of change should jog your memory as just regular old slope. So to find the average rate of change, I need t of 24 minus t of 0 over 24 minus 0. So in order to figure this out, I'm going to go to my window. I'm going to make sure that my x values go up to at least 24. So normally your window is going to look like this. Oop, it's thinking. Normally your window is going to look like this. I'm going to make sure that this goes up at least to 24. So I'm going to go to like 26 or something. And then I'm going to be able to use the trace feature to get some y values. Looks like somebody's been reformatting my calculator a little bit. So now, even though I can't see the graph, I know it's there. I'm going to click on Trace 24, Enter, and it's going to tell me my Y value is 56.927 or 926. So I would have 56.926 minus, I'm going to click on Trace and hit 0, and I get 70 over 24. So now I'm going to go back to my home screen and I'm just going to type this in. So 56.926 minus 70 over 24, and I get negative 0.544. Now it does say specifically in these instructions, include units on your answer. My units for a rate are going to be change in y over change in x. Since I'm measuring degrees Fahrenheit per hour, my units would be degrees Fahrenheit per hour. In the next problem, it says, what is the rate of change of the temperature at t equals 4 hours? Now, there's a difference between the way that these two problems were written. The first one says the average rate of change, and this just says the rate of change. The second difference is this says over the 24-hour time period, and this says at 4 hours. When you see that, that should tell you this is a derivative. It's a rate of change at a single point. So in other words, I want to know t prime of 4. I'm going to go to math option 8, which is take the derivative. I'm going to tell the calculator to recall my y, and I'm going to say plug in the number 4, and it's going to give me negative 0.916. Now, in spite of the fact that this is a different type of rate of change, so it's a derivative, we're still finding a rate. So it's still going to be the same units, which are degrees Fahrenheit per hour. So this is a derivative. Last but not least, if it says, what was the average temperature over the 24-hour time period? If I just say what was the average score on a test, I would say add up all your test scores and then divide. So if I want to find the average temperature, I need to add up all my temperatures and divide, which means I need to do an average value. So I would do 1 over 24 minus 0, so it's a 24-hour time period, and then the integral from 0 to 24 of my t function. Now again, you have your calculator, so I'm going to type in 1 over 24, and then I'm going to go to math option 9 from 0 to 24. I'm going to tell the calculator to recall my y variable, and then I'm going to hit enter. 64.026. Now, as far as units go, if I add up all my temperatures and I get the average temperature, that's just going to be measured in degrees Fahrenheit. The reason is because this guy right here would be doing degrees Fahrenheit times hours. You're multiplying because you're doing an integral. But then this guy right here is doing 1 over the hours. So the hours cancel and you just get degrees Fahrenheit. It also logically makes sense. If you do an average temperature, it's going to be measured in degrees Fahrenheit. It's not going to be measured in degrees Fahrenheit per hour. You're not finding a rate. All right, we will talk about problem number 4 when I see you in class tomorrow. Thank you guys so much for watching and have a great day.